All right, 2.3, real world problems and mathematical modeling. Mathematical modeling is like the process in which we use math to replicate a real world scenario, kind of like predicting the stock market, predicting how many defective bulbs or, I don't know, iPhones or whatever there is in like 5,000. All right, so we can use math to kind of solve real world problems. Okay, a big thing in the world is markup. Markup is kind of like when you buy something, um, there's a markup on it. And what do I mean by that? Well, in reality, like, I don't know, let's just say a pair of shoes. You have the raw materials for the shoes and you have the labor to put it together. So a pair of shoes might actually only cost like $8 to make, but they're marked up so that people can, get a profit. Now, why do they do that? Well, the shoes don't get made in the store. They get made in a factory, and that factory has like, let's say they have their mortgage to pay, insurances, they have their people to pay, and then they have to ship it to you. And then that store has their mortgage and insurance, and they have to pay their workers and signage. So things get marked up. So markup rate is the percentage of cost. So here, the selling price of a jacket in a department store is $157.14. The cost of the jacket to the store is $130.95. What is the percent markup? So what we have to do is we have to find out numerically how much it was marked up. So everybody start out with doing 157.14 minus 130.95. Okay? And then what I'm going to do is I am going to find that, and that's going to be using my handy dandy calculator. 157.14 minus 130.95. That's going to be 26.19. And then from there, I'm going to do 20.19. And I'm going to divide it by 130.95. And I get 0.2. And as a percentage, that is 20%. So this is a 20% markup. All right, I'll be right back. I have to go get it right now. All right, so I got 20%. Let me scroll down. Now it says a department store sells a sweater for $60 and the cost of the sweater to the store is $35. So I do 60 minus 35 and I'm going to get a solid $25. Okay? And from here it says, what is the markup? So this is the markup. And now it says, what is the markup rate? So I'm going to do 25 over 35. And I get, let's see, that's going to be 5/7, which is going to be roughly 70% markup. 71.4. So 71.4% markup. Any questions? Franklin?
No.
All right, cool. All right, so now let's find the discount rate. So the discount is based upon the list price, and it's the deduction from the original. So the discount rate, I'm going to be doing the same process here. So a department store sells a beach towel for $32, and the beach towel actually sold for $24. So what is the discount? So I do 32 minus 24, and I get $8. This is the discount. And now to find out the discount rate, okay? So it was originally being sold for 32. That's the number I'm going to use. So I do 8 divided by 32, and I get 1/4, which is 0.25. So it would be a 25% discount. The shoe store sells a pair of athletic shoes for $75, but they go on sale for $45. So what is the discount? So 75 minus 45, that's $30. That's my discount. And then 30/75, that's going to be 6/15, which is 2/5. So that's what, 0.4? So 40% discount. Hopefully you guys are checking me. I'll slow down for a second for you guys to go. So it's just like me here, and then you'll log on and we will do until like the kids like come back in, and you'll like help us monitor the chat and things like that, and you get so there's a problem, you can tell me to slow down, and then there's an issue, and then yeah, because you can't see. Yeah. Or you can't see that. So that's why we want sci-fi guys. Yes. Yeah, I'll set that. All right. Ooh. Let's move on to C. Now, did anybody move on to C before me? Did anybody do it? Ed, did you do it?
No.
Ooh, emphatic no. I like that. So, Ed, we got, if a product is discounted by $4 and is selling for 16, what is the original price? So if the discount is $4 and it's selling for 16, Well, then I have to add that. So it'd be $20. So that's the original price. It says, what is the discount rate? Well, the discount rate would be 4 over 20. Now, why is it 4 over 20? Because it's the original cost that I have to take into account here, not the sale price. So 4 divided by 20 is 1/5, and that's 20%. Justin, am I moving too fast here?
No.
All right, cool. Remember, just shout if I need to slow down. All right, labor rate. So the bill for the repair of an automobile is $380.
Mr. Harmon.
Yes, Jake. Jake? Is $380. Included in this bill is a charge for $275 for parts, and the remainder of the
Mr.
bill.
Harmon, can you hear me?
Yes, Jake. What's up?
Well, I can't hear you, so I'm going to exit and then come back in. Is that okay?
Sounds great, Jake. So it says the charge for labor is $35 per hour. How many hours were spent in repairing the automobile? So what I need to do is figure out how much of my bill was spent on labor. So it says $380 was my total, which is not too bad. And $275 was for parts. So if I subtract those two, I get $105 for labor. But it's $35 an hour. So if I do 105 divided by 35, I get my answer, which is 3 hours. And now an auto repair bill is $338. All right, 170 for parts and the rest for labor. So I do 338 minus 170, and I get 168. And it says it took 6 hours to repair the automobile. So what was the hourly rate? So I do 168 divided by 6, and I get, let's see, 2 and is it 48? So 28 hours or $28. So it was $28 per hour. So for these, it says the formula we use distance equals rate times time. Okay. So for instance, if you travel a constant rate of 55 miles per hour for 45 minutes, the total distance you traveled is what? Well, my problem here is 45 minutes. 45 minutes is 0.75 hours. So I need to make that conversion right out the gate. So if D equals RT, and I want to know how far I traveled, I have distance equals my rate, which is 55 miles per hour, times 0.75 hours. And that's going to be, let's see, 13.75 times 3. So that's 41 0.5 miles. Did I get that right, Cody?
41.25.
Oh,
Close enough.
doesn't count. We're not playing horseshoes here. Unreal. Should stick to my day job and be a cop. Now, the reason why I'm bringing this up and telling you about this is I don't know if you guys heard this rumor, but they were looking on the toll roads to actually give you a citation. All right? They were going to fine you because they set the speed limit to like a certain amount, like on the PA Turnpike, it's like 65. And they know the distance between tolling booth and tolling booth. And what they were going to do was they were going to calculate that and put timestamps on it. And if you got there too quickly, they knew you were speeding. So they would send you a citation in the mail. Fortunately, they did not do that yet, but it's probably coming. Now
When do you think it's coming?
why?
No, when?
I don't know. When are you going on the turnpike?
I don't know. I'm just wondering.
That day, it's going to start.
Okay. Yep.
Careful when you're driving through Breezewood. I got a ticket there once. Worse. Come down off the mountain. Unreal. How long will it take you to ride a bike 30 kilometers at 18 kilometers per hour? So I have distance equals rate times time. So I have 30 kilometers. And my rate is 18 kilometers per hour. We'll do kph. All right, and I want to know how long. So I have to divide here. So 30 divided by 18 is, let's see, 3. So 5/3, okay, hours. So that would be 1 hour and 40 minutes. That's what I'm going with. 1 hour and 40 minutes. Am I right? Who do I want to pick on? Laura, am I right? 1 hour, 40 minutes? Or are you confuzzled how I got that?
I know how you got it. I just didn't do it on the calculator. Hold on.
Nikki, are you good with that? Mr. Grantland? Probably left. All right, a train can travel a distance of 252 kilometers in 2 hours and 15 minutes. Well, there's a problem right there. I can't have 2 hours and 15 minutes. I need to have it as 2 hours and 15 minutes is a quarter of an hour. So I need to write that as 2.25 hours. What is the average speed of the train? So I'm going to do 252 kilometers divided by 2.25 hours. Oh boy. I'm not doing that one in my head right now. So once I divide that, I get 112 kilometers per hour. Almost done. We got like 5 or 6 problems left. 2 trucks leave at approximately the same time and travel the same route. How far apart are the trucks after 4.5 hours? if their average speeds are 52 miles per hour and 56 miles per hour. So, truck one in blue. Truck one, all right, we have distance equals rate times time. And we're going to find the distance from the depot. And this will make sense at the end. So the distance is the rate, which was 52 miles per hour times 4.5 hours. Now, 52 times 4.5 is 234. Yeah, it is. So truck one is 234 miles away from the depot. Truck two. You do the same thing, but this one's traveling at 56 miles per hour. So that one, 224, this is going to be 60. 52. What is it? 252? Maybe, hoping. Now I have truck one, 234, and truck two at 252. So I subtract them. And I get what? 18? So they're 18 miles apart. Another way to do this is you could have subtracted their speeds. So it would have been like 56 minus 52, and you would have gotten 4. And 4 times 4.5 is 18. Two planes leave Chicago O'Hare's International Airport at the same time and fly in opposite directions. Okay, so you have one plane flying that way, and then you got one plane flying that way. Man, I really wish this board was long. All right, it says, how far apart are the planes after 1.5 hours if their average speeds are 480 and 600 miles an hour? So what I'm going to do is I'm going to do distance equals rate So the rate for this one is going to be 480. And it says 1/3. I'm going to write that as a fraction. So that's 4/3 hours. This one, this is, all right, 600 miles per hour times 4/3. So this plane is 160 times 4. Yeah, slowed it down. 640 miles away. And this one's 800 miles away. And if I add the two, my answer is 1,440 miles. So that's how far apart they are. All right, 3 problems kind of left. Record the formula for simple interest in your notebook. Interest equals principal times rate times time. Find the annual interest rate on a CD that accumulates $400 in interest in 2 years on principal of $2,500. So I want to know the interest. So I'm going to say I equals principal, that is $2,500. The rate is 2 years. And, oh, gee, killing me. Oh, my bad. And I want to know the rate. So I need to find, oh, it says the interest is 400. So let's fill that in. So if we have 400 as my interest on $2,500 for 2 years, I'm going to divide these things. So I have 400 equals 5,000 times my R, divide by 5,000. My rate would equal 4 over 50, which is what? 8%?
Yes.
So it's 8% interest.
Wait, I have a question.
Can you hold it till the end, Jake?
Yeah.
A deposit of $8,000 earns $300 in interest in 6 months. What is the annual interest rate? Same thing, 300. All right, equals 8,000 times, now it says my rate, so I'll put R in, and my time is half a year. So if I do that math real quick, 1/2 of 8,000 is 4,000. R, and then if I divide those, I get my rate equals 3 over 40, which would be 7.5%. So it'd be 7.5% interest. And then it asks, at this rate, how long would it take to earn $800 in interest? So if I write $800 equals 8,000, and we had our rate was 7.5%, and we want to find T. So if I do 7.5%, so 0.075 times 8,000, I get 600. So 800 equals 600 T. divide by 600, and I'm going to get t equals 8/6, which is 4/3, which is 1 year. And a third of a year is 4 months, so I'm going to write 1 year and 4 months. Or 1 1/3 year.
Wait, where did you get the 600 from?
All right. And, oof. And we're not going to do that problem because I don't have time to do it. So let me